Hey everyone, welcome back to the channel. So today we're going to build an AI stock price predictor using Facebook Profit and Python to model the S&P 500. But more importantly, we're going to look at what happens when you actually test this on real market data and why standard time series models often struggle with the stock market. So if you want to see more content like this, then make sure you hit that like button and subscribe to the channel right now. Let's go ahead and jump into code. So currently I'm on Google's website called colab.research.google.com because it makes it easy to get started programming in Python. If you want to code along with me, just go to the website and then log in with your Google account to get started writing your Python code. Okay, so the first thing that I'm going to do is I'm going to put in some comments here, and I want to import the libraries that I'm going to be using for the program. Next, I'm going to import pandas as PD. And then from profit, I'm going to import profit with a capital P. And from sklearn.metrics, I want to import mean absolute error. Okay, and then I'm going to run this cell by clicking this button right here to the left, and I get a check mark. So let me know that everything is good. Let's create a new cell by clicking that code button in the top left. Now here, I want to load the S&P 500 stock data, and I happen to have that already loaded here. So there it is. It's called sp500.csv. And if you want to load your own file, you can just click this upload button here, right there. All right, so let's go ahead and take a look at this sp500.csv file by double clicking it. And I'm going to exit out over here. Okay, and we can see that the data starts from 9/9/2010 or September 9th, 2010, and it goes all the way to 7/2/2026. So that's July 2nd, 2026. And then if we go back here, we can see our date column. We can see our open price column, our high price column, our low price column, our close price column, our adjusted close price column, and the volume column. All right, so let's go ahead and exit out of here now that we've taken a look at the data, and let's go ahead and load it. So we're going to create a variable called df, which will be short for data frame, and we're going to set it equal to pd.read_csv, and then we're going to input the name of our file, which is sp500.csv, and that should load our data set. All right, however, profit requires columns named ds and y, and I'm going to put that in comments here. Profit requires columns named ds, which is the date, and y, which is the value. Okay, so we're going to go ahead and create those columns. So we're going to set df equal to df, and we're going to use two square brackets, and we want our date column and we want our close price column. So our close price column will be our value, and we want to rename these. So I'm going to type dot rename, and we want to rename the columns, right? So we're going to set columns equal to, we're going to use curly brackets here, and we're going to put date and then colon. The new name will be ds, and then comma, we're going to put close colon, and then the new name will be y, and that should do it. Okay, next I want to make sure that we're going to be using a date time data type for ds. So now that we have our ds column, I'm just going to type here df and then put in the new column ds, and I'm going to set it equal to pd.to underscore date time, left parentheses, right parentheses, and then in here we're going to put in our ds column. Okay, so let's go ahead and run this, and we get a check mark. Everything's good. We're going to create a new cell. All right, next we're going to go ahead and split the data into 95% testing data and 5% training data. Okay, so I'm going to use a index variable to help me with this. So I'm going to create a variable called split underscore index, and I'm going to set it equal to the length of our data frame or our data set, and I'm going to multiply it by 0.95. So that should be 95% of the data. And I'm going to cast this as an integer. All right, and that will give me my index. Okay, so next let's go ahead and create our training data set. So I'm going to create a variable called train, and I'm going to set it equal to df.ilot, and then my square brackets. And I want all of the data up to the split index. Okay, so this should be 95% of the data. All right, next I'm going to create my test data set. I'm going to set it equal to df.ilot, and I want everything from that index onward. Okay, so now we've created the training data set and we've created the testing data set. So again, our training data set contains 95% of our S&P 500 data set, and then the test data contains 5% of our S&P 500 data set. All right, so let's go ahead and run this cell. Let's create a new cell and come on down here. And now we're going to train the model. Okay, and I should also put create. So we're going to put create and train the model. All right. Okay. So I'm going to create a variable called model, and we'll set it equal to profit, left parentheses, right parentheses. And in here, we're going to put in daily underscore seasonality, and we're going to set it equal to true. Okay. Now we've created our model. Next, we're going to train our model. So we're just going to type model.fit, and fit is another name for train. And what are we fitting the model on? What are we training the model with? What data set? Well, we're going to be training it with our train data set. Okay, so that should do it. Let's go ahead and run this cell, and this will take a little while. And let's create a new cell. Okay, and we see that we got a check mark, so everything's good for training the model, creating and training the model. All right, so next I want to create the future data frame only for the test period. Now, the idea here is that we're going to see how good our model is on this test data, right? And what is the test data? The test data is 5% of our S&P 500 data, and it's the last 5%, right? So we're going to see if our model can make predictions, if it can predict the actual values that are on the test data, all right? And those values being the close price. All right. So I'm going to create a variable called future, and I'm going to set it equal to model dot make underscore future underscore data frame, and periods will be equal to the length of our test data, and the frequency will be equal to daily. Okay, and I think that, yeah, daily. So the frequency may be off a little bit here, but that's okay. This is just a fun program. So let's go ahead and run this. Okay, what did it not like? I did not like that I misspelled periods. So let's run that again. Okay, now let's go ahead and create a new cell. And what are we going to do in this cell? We're going to get the model's predictions. Okay, so let's do that. So we're going to type here, or let's think. We're going to create a variable. We're going to call it forecast, and we're going to set it equal to model.predict, left parentheses, right parentheses. And we need to put in the data that we want to predict on. So we want to put in the dependent variable so that we get our independent variable, right? So what's our dependent variable? In this case, it's future. So it's going to be those future dates. So we're going to put in future here. And so now that we have those future dates, we can get those future prices. All right. Okay. So I think that's good enough. Let's see. Next, I want to go ahead and extract only the rows that correspond to the test period. So I'm going to create a variable called pred, which will be short for prediction. And I'm going to set it equal to forecast.ilot and then square brackets. And I'm going to put negative length of our test data and then colon. So what is this doing here? So I'm telling the program to start at the row that is len test rows from the n. So len test is going to be some number. So we'll just call it n, right? So let me say that again. We're going to start at the row that is n rows from the n. Okay. And I only want certain columns. So I'm going to put double square brackets here and I'm going to tell it what columns I want. So I want the DS column. I want the Y hat column. I want the Y hat lower column. That's going to be the lower bound. And I want the Y hat upper. Okay, so that should do it. Let's go ahead and run it. All right, let's create a new cell. All right, now in this cell, we are going to plot the data. So I'm going to create a variable called fig and set it equal to model.plot. And I need to tell it what to plot. So we're going to put in forecast here and then type fig.show, which might not even be necessary. But let's go ahead and run this. And here we go. So in black, what you can see are the actual data points from our training data set. And then this last little bit here would be where our test data set would be. And this is what the model's trying to predict. So the model's in blue. The dark blue line is the model's predicted value for the stock. And then up here would be the upper bound. And then down here will be the lower bound. All right, let's create a new cell. Ah, very nice. All right, we're almost done. So now in this cell, we want to compare the actual values with the predicted values. So I'm going to create a variable called comparison. I'm going to set it equal to pd dot data frame. And then we're going to do left parentheses, right parentheses, and then do curly brackets. All right, so we're going to create a data frame and we're going to give it a date column. And what are we going to put in this date column? That will be the test data's date. All right, next we're going to create a column called actual, which will contain the actual price of the stock. So we're going to get that from test y dot values. And then we're going to create a column called predicted. So it's going to contain the predicted values. So that's going to be from our pred variable. And we want y hat here dot values. And again, that's going to be that dark blue line, right, that you see in the plot up here. It's that dark blue line. All right. And now let's do lower bound. So that's going to be pred y hat lower, y hat lower dot values and upper bound. So now we have our upper bound column, pred y hat upper dot values. Okay, let's go ahead and continue. And let's print, put a new line here. So \n, and I'll put actual versus predicted. Okay. All right. So we're just going to print comparison. And actually, I only want to print, let's just print the last 10 rows. So we'll do comparison dot tail, and we'll put in 10 here. All right, so let's go ahead and run this and let's take a look. All right, so we can see our date column here. We can see actual here. We can see predicted and lower bound and upper bound. Okay, so what does this mean? What are we looking at here? This means on June 18th, 2026, the actual value from our test data set was $688 and about, I'm just going to say 11 cents. I'm going to round it up. The model predicted the value to be $622 and about 73 cents. So the model was definitely off, right? And then the model was about 80% confident that the price would not get lower than $603 and about 87 cents. And it was also about 80% confident that the price would not be above $641 and about 73 cents. But obviously, the price was above that 641, and that is very interesting. So again, if we look at this upper bound, right? Profit again is about 80% confident that the price won't exceed 641. All right. Yet the actual market price is sitting aggressively, might I add, at 688. So it completely broke the model's safety net. So that's why you must keep in mind that this is just a model, right? And then also something else, if you look at the predicted values, it goes from about 622 to about 625, right? So if you look at that, it's basically like a flat line. So it barely moves. And profit might be drawing just a smooth seasonal line here, and obviously it can't see market momentum or news, things like that. So maybe that's what's happening right here. Anyways, this is our model. Let's go ahead and evaluate it. So I'm going to create a new cell. And here we're going to put evaluate the model. So we're going to create a variable called MAE and set it equal to mean underscore absolute underscore error. And what are we putting in here? We're going to put in our test values, and we're going to put in our predicted values. That's y hat. Okay. And let's go ahead and just print this. So I want to print mean absolute error, MAE, MAE. All right. And let's run this. Okay, so we get a mean absolute error of about 32.43. All right. Or we just say 32.4. And so when printing MAE, which is about 32.4, this explains, or this shows that the model is off by about $32.40 per share on average. And that is approximately, if I'm doing my math right, maybe four, or it might be a 4 or 5% error, right? So it might be a 4 or 5% error between these values. Yep, I think that's right. And a 4 or 5% error sounds kind of small in standard machine learning. However, a 4 or 5% directional miss in live trading can completely wipe out a leverage account. All right. So that's it. What's the takeaway? Profit is fantastic for things driven by human habits like website traffic or retail sales. But the stock market is a bit more chaotic and a bit more complex. And a simple history and trend model can't fully capture everything. But again, it is just a model. And, it was kind of close. Um, but if you want to grab this exact Python script and the S&P 500 data set to play around with yourself, you can get access to all of it over on Patreon at patreon.com/computer science. And I will leave a link for that in the description below. Your support there honestly keeps this channel running. And let me know what models we should try next, maybe LSTMs, GARCH. Drop a comment below with your suggestions for the next video. Thank you for watching. I hope this was very educational. I hope it was entertaining for you all. And try your best to improve these models. And I'll see you in the next video. Bye-bye.